In computer science, threat modeling usually starts at the terminal. We train to analyze malware, audit cryptography, and configure complex firewalls to protect the logical layer of our networks. This software-centric focus creates a vulnerability. Sophisticated encryption offers no protection if an adversary targets the physical infrastructure transmitting that data. A simple pair of wire snips can efficiently sever a critical communications cable, achieving a total network bypass without writing a single line of code. For larger targets, adversaries utilize heavy machinery to enact large-scale physical disruption against buried network infrastructure. In modern conflict, the logical and physical realms are intrinsically connected. Securing a network requires accounting for the physical destruction of OSI Layer 1. The doctrines that dictate traditional physical warfare map directly to modern cyber conflict objectives. In traditional military doctrine, commanders deploy direct fire weapons, like advancing tanks, to achieve localized physical dominance over a specific target. Indirect fire tools operate on a broader scale. Artillery bombardments disable wide swaths of enemy infrastructure, mirroring the systemic disruption seen in a cyber-based denial of service. Before either strike occurs, military forces rely on satellite imagery and espionage for physical reconnaissance, a principle that applies identically to the footprinting phase of a cyber attack. Understanding how state-sponsored actors compromise digital systems requires analyzing how they target physical infrastructure in the real world. When we map physical attacks to the CIA triad, confidentiality, integrity, and availability, these assaults primarily target network availability. However, if an adversary gains direct physical access to hardware, they can bypass digital access controls and compromise data confidentiality as well. Look at the internal strands of this fiber optic transit line. These strands are fragile, making the backbone of global communication susceptible to precision cuts. Attackers also employ a secondary strategy, targeting the external power systems that support critical network nodes. Destroying a supporting power substation creates a localized physical denial of service, without the attacker ever interacting with a server. Adversaries also target the personnel involved in network operations, physically hindering the human workforce required to mount a recovery effort. By physically denying power, connectivity, or human operation to a specific node, precision physical attacks bypass logical security. Electromagnetic assaults are effective tools of cyber warfare because modern infrastructure relies on sensitive electronics to function. EMP, or electromagnetic pulse weapons, generate a powerful energy field that permanently disrupts non-hardened electronic circuitry. An EMP is a burst of electromagnetic radiation that can be produced by nuclear explosions or specialized non-nuclear devices. While prevalent in science fiction films, actual EMP deployments are rare, but when they are executed, they are entirely devastating. The most severe threat is a HEMP, or high-altitude electromagnetic pulse. HEMP is an effect created by detonating a nuclear weapon in the upper atmosphere. A single HEMP device detonated at high altitude covers a vast geographic region. Its deployment indicates a severe global conflict. For localized strikes, adversaries use HPM, or high-power microwave weapons. HPM devices use chemical explosives or high-capacity batteries to produce a short pulse of microwave energy that disrupts electronics. It impacts a smaller area than a HEMP, but is highly effective against specific electronic systems. Beyond physical destruction, electromagnetic assaults easily disrupt and jam standard electronic transmissions across the targeted spectrum. Furthermore, adversaries intercept electronic emanations leaking from active equipment to gather intelligence before the attack even begins. Electromagnetic weapons represent a massive area of effect cyber-physical attack, capable of wiping out thousands of logical nodes instantly. Defending against these kinetic and electromagnetic threats requires rigid physical security measures. It starts with a hardened physical perimeter, utilizing security personnel, razor wire, and electrified barriers. Facilities deploy heavy force protection structures, like reinforced concrete bollards, to deter targeted vehicle attacks. To protect against invisible electromagnetic threats, buildings must meet Tempest standards. Tempest is a rigorous set of specifications designed to protect equipment from leaking sensitive electronic emanations. These standards ensure that information-carrying signals are not intercepted through unintentional radio or electrical leaks. Tempest-certified structures are heavily shielded against internal signal leakage, highly resistant to EMPs, and blast-hardened against kinetic strikes. When external power systems drop during an assault, the facility relies on redundant infrastructure to maintain continuous network connectivity. This requires massive, uninterruptible power supply banks and industrial backup generators permanently standing by on site. Ensuring network survival requires layering rigid physical barriers, structural electromagnetic shielding, and deep power redundancy. However, the most hardened Tempest facility fails if the human operators inside do not secure their physical environment. This requires strict OPSEC, or operation security. OPSEC is a process that identifies and protects sensitive, unclassified details that an adversary could piece together to compromise a facility. This practice involves analyzing a facility from the perspective of an attacker to identify potential security gaps. Effective OPSEC relies on continuous workforce training, instructing personnel to protect sensitive documents and physical equipment. Policies explicitly forbid discussing work details publicly or online, as this directly aids adversary reconnaissance efforts. Organizations must encourage constant risk assessments and daily routines to build a culture of security awareness. Human discipline is the vital protocol that seals the gaps between physical barriers and logical firewalls. Cyber warfare is a full-spectrum conflict that operates across both logical and physical domains. The keystrokes inside a terminal and the kinetic force of a physical strike operate toward the exact same strategic objectives. True defense in depth dictates that securing OSI Layer 1, the physical hardware and power grid, is just as critical as securing the application layer. As network engineers, your threat models must step outside the terminal and account for the physical vulnerabilities of the infrastructure. The ultimate security of any digital system is exactly as robust as the physical ground it stands upon.